Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Today our class focus on chapter 2. Okay, subtopic our chapter 2 is electrical system. Okay, before this we talk about mechanical system. Okay, so mechanical system there are two types. Okay, first translation and the second one is rotation. Okay, same as mechanical. So for electrical system, okay, first you need to modeling mechanical equation, and then after you modeling mechanical equation, you can find the transfer function. Okay, this one is the idea or concept of electrical network transfer function. Okay, so basically for the electrical, okay, there are three passive linear component. Okay, first resistor, second one is capacitor, and last one is inductor. Okay, so same as mechanical. So for electrical, so we combine all electrical components or some electrical component into circuit, and then we decide the input, and then we decide the output to find the transfer function. Okay, so for mechanical we use Newton's second law, but for the electrical we use the concept of Kirchhoff's law. Okay, basically for Kirchhoff's law we have two. Okay, one is KVL and then second one is KCL. For KVL is the summation voltage around loops equal to 0. Another one, KCL, is the summation current at nodes equal to 0. Okay, so after you choose the concept, either you want to use KVL or KCL, okay, you write the differential equation, and then from this differential equation you can take your Laplace transform, and finally you get the transfer function. Okay, this one is the relationship of capacitor, resistor, and inductor in terms of voltage current, voltage charge, and also impedance. Okay, so you can see here there are three components: capacitor, resistor, inductor, and then you can choose either you want to use a voltage current or current voltage. Okay, so this one is the equation for capacitor, resistor, and inductor. Okay, for voltage and current, and then current voltage, and also you have another equation for voltage charge. Okay, how you want to choose, how you want to know which one we how okay, how you to choose. Okay, either you want to use this one, voltage current or voltage charge. Okay, it's a depend what is input, what is output. Okay, so you want to solve, you first must know what is the input, what, and then the second one what is output. Okay, it's a better you try and error for this method. Okay, today I want to show you the one example of simple electrical system. Okay, so this one we only have single loop. Okay, and then the question asks find the transfer function relating the capacitor voltage DC and then to the input voltage. Okay, so you refer this figure, you can see this one is a voltage capacitor, and then this one voltage input. Okay, how to solve this problem? Okay, so first, you want to find transfer function for VC. Okay, VC is a output. Okay, and then V is a input. Okay, so first, we use KVL. Okay, so we use KVL. Okay, which is the summation of V equals 0. And then okay, based on the figure, okay, so you can, okay, based on the figure, you can, you found that, okay, VL plus, okay, VL plus VR plus VC equal VT. Okay, so this one is a, okay, you can, this one, okay, this one is a minus plus, okay, plus minus, okay, plus minus. So that is why you get this equation. Okay, for this equation, you uh, find the relationship between voltage current. Okay, so based on previous table, you get, okay, L di over dt plus Ri plus 1 over C integrate 0 to T IT dt equal Vt. Okay. And then, okay, so to get VC, because we know that VC is the output, okay, and then first you need to replace IT into charge, okay, which is IT equal dq over dt. After you convert, after you replace IT equal dq over dt, you get this one, okay, L d square q divided by dt square plus r dq over dt plus 1 over c qt equal vt. And then from this equation, okay, you convert qt into cvc. And then you just replace qt by cvc, and then you get this one. LC d square VCT divided by dt plus RC dVC divided by dt plus 1 over C CVC equal VT. Okay, so you get a differential equation. Okay, so you want to find the transfer function. Okay, next step is you taking Laplace transform. Okay, so you get this one. Okay, L multiply C multiply S square VC plus RC S VC plus VC equal V. Okay, so for this equation, you factorize, and then lastly you get VC over V divide VC over V equal 1 over L S square plus RC S plus 1. Okay, and then finally you can see the this one. Okay, so you get, okay, this one. Okay, VC divided by V equal 1 over LC divided by S square plus R over LS plus 1 over LC. Okay, so this answer for the simple single loop using differential equation. Okay, and then this one is a block diagram. Okay, so in output divided by input. Okay. Okay, summary for electrical network. Okay, so you have capacitor, resistor, inductor. Okay, so this one the relationship between voltage and current. Okay, for capacitor Vs equal 1 over Cs multiply Is. Okay, for the resistor Vc equal I Is. Meanwhile, for the inductor, Vs equal L multiply S multiply Is. And then the impedance for current voltage, okay, this one, okay, V divided by I equals Z, okay, because this one voltage is a output, I is a input. Okay, that's all for electrical. Okay, so next I will show you the equation, show you the problem of two loop. Okay, the next video. Okay, that's all. Hopefully you understand. Okay, if you do understand the concept, okay, you can see this video more and more. Okay, that's all. Thank you.